In this video, I'm going to look at differentiating inverse trig functions. This is very similar to the last video that you saw, which was about differentiating inverse hyperbolic functions. Let's look first at arc sin x. I've drawn the graph of arc sin x for you. Remember, to make it a function, we have to restrict the range. Y has to lie between minus pi by 2 and plus pi by 2, inclusive. If we carried on, we would no longer have a function. Okay, having said that, let's differentiate y equals arc sin x. The first thing that we need is to take sine y is equal to x. Differentiating with the chain rule, we get cos y dy by dx is 1, and therefore dy by dx is equal to 1 over cos y. We should all know that cos y is root 1 minus sine squared y. And here we need to ask the question about plus or minus. Since y is in the region minus pi by 2 to pi by 2, cos y has to be non-negative. Therefore, it is quite correct to take the positive square root. Cos y cannot be negative, therefore we must be dealing with root 1 minus sine squared. At the extremities, pi by 2, sine y is 1, this becomes infinite, but at the extremities you can see the gradient is infinite, so that's fine. Sine squared y is x squared, so this now gives us that when we differentiate arc sine x, we get 1 divided by root 1 minus x squared. Differentiating the other trigonometric inverse functions is very similar, and the plus or minus on the square root sign in each case can be justified in the same way as I have just done it with arc sin x. So if we come to differentiate something like arc tan root x squared minus 1, the first thing we have to do is to remember that if I differentiate arc tan x, I get 1 over 1 plus x squared. So now it's just a case of using the chain rule. dy by dx is going to be equal to, that's arc tan u, 1 over 1 plus u squared times du by dx, a half x squared minus 1 to the minus a half times 2x. The bottom line here is 1 plus x squared minus 1 is 1 over x squared times x squared minus 1 to the minus a half is 1 over root x squared minus 1. 2 and 2 cancels times x. And so I get that dy by dx is equal to 1 over x root x squared minus 1.